see valid anagram. An anagram is a word or a phrase formed by rearranging the letters of a different word or a phrase, typically using all the original letters exactly once. For example, we will be given two strings, S and T, and we need to say if it is an anagram or if those two are anagrams or not, and return true or false accordingly. Suppose, example, we are given S equal to anagram string, T is equal to anagram string. So if you see that, if you rearrange, T is formed by rearranging all the letters in S. How we can go about doing is we can use a hash table to first map out all the functions, all the characters in S. So let's say we are mapping it out with its corresponding counter. So A is occurring 1, 2, 3, 3 times. N is occurring 1 time. Then G is occurring 1 time. R is occurring 1 time. M is occurring 1 time. So this is the frequency count of the letters in the first string. Now we need to see if T also has the same frequency count. So let's call this as H1 and let's call this as H2. If we see that N is having count 1, A is having count 3, G is having count 1, N, A, G, A, R is count 1, M is having count 1. So basically, if you rearrange this in the same order, we can say that H2 and H1 are same. So basically, if the frequency count hash table of both the strings are same, if we compare H1 equal to H2, then we can say if it is an anagram or not. Also, instead of using a separate hash table, we can use the same hash table to do it. So what we do is first we traverse to the first string and create the first hash table, and then we traverse to the second string and see if any of these letters are present in the hash table. So we will see if N is present, we will go and reduce the count. A is present, so we'll reduce the count. G is present, we'll reduce the count. A is present, we will reduce the count. R is present, we'll reduce the count. A is present, we'll reduce the count. M is present, we'll reduce the count. So at the end of the traversal of the string, we can say that this hash table has this frequency distribution with all the letters having its corresponding mapping value as 0. So we will see if all the letters in the hash table has a value 0, then we can say that it is an anagram. Suppose what will happen is that the second string will have a character which is not present in the first string. Then during the traversal, after M we will hit T, we can say that it is not in the hash table. Then immediately we can return false, saying that it is not an anagram because that T was not in the initial string. Now let's code it up. So what we need is we can either code up the frequency using this counter function, else we can code it up directly using a for loop. So immediately we can do one check, is that if length of S is not equal to length of T, then we can immediately return false because it is not anagram. If the length are not same, then obviously it is not an anagram. Then we will create the hash table. Okay, so we can either use the counter function like this. This will provide the hash table, or we can do this also. So I'll write the code and then we'll for character in S, If ch not in s, then we will add that character with the count of 1, else we'll just increment the count. So this is one way of doing it. Okay, because we are already using the counter function. Then in another loop we are going to traverse the second string. If ch not in h, we can immediately return false, else we will decrement that count. Okay, and then we need to return after checking if all the values of that hash table for in h dot values are equal to 0. Okay, let's run and see. Okay, let's see the counter functions in Python. Collections, from collections import counter. Okay, okay, yep, we have submitted. The time complexity of this will be O of n, and space complexity will be O of n, because we are using a hash table to store the string, so the length of the string will be equal to the hash table length. Therefore space and time complexity will be both O of n. Time complexity will be O of n, and space complexity will also be